So what we're going to do in the last section of Unit 6 is review some information that we talked about back in Algebra 2 and apply it to some different scenarios, and that is the real zeros of a polynomial function. Like I mentioned, we're not going to get into imaginary zeros. A theorem that you learned in Algebra 2 was about the number of zeros. Remember, a polynomial function cannot have more real zeros than its degree. So for example, if it's an y equals x to the fourth, we know the degree of this polynomial is 4, so therefore at most it can have 4 real zeros. It doesn't have to have exactly 4 real zeros, but it can have no more. Now there's one theorem that may be new to us, and that's called the rational zero theorem. So this is just listing the possible, not the actual rational zeros of a polynomial function. So I call this the P over Q test. P is the factors of the constant term. Q is the factors of the leading coefficient. What you're going to do is you're going to take all combinations of factors of P. So in other words, you take the factors of your constant, you divide them by the factors of the leading coefficient. And again, P and Q must be real numbers or real coefficients. So let's take a look at an example of, and again, I'm just going to try and refocus this. It seems like it's out of focus here a little bit. There, I think that's better. So for example, given the polynomial 6x to the fourth minus x squared plus 2, remember the constant is the term that has no variable with it. So there's my constant. So I want to find the factors of my constant. So again, when I say factors, the numbers that multiply together to give us 2. So it could be positive 1 and positive 2, or negative 1 and negative 2. So I can write this as plus or minus 1, plus or minus 2. Because 1 times 2 is 2, negative 1 times negative 2 is also positive 2. Next, I want to find the factors of my leading coefficient. Again, the leading coefficient is the coefficient of the variable with the largest exponent. So this is my leading coefficient. So I want to list the same idea, the numbers multiplied together give you 6. Well, plus or minus 1, because 1 times 6 is 6, plus or minus 6. Plus or minus 2, plus or minus 3, because 2 times 3 is 6. Now what you're going to do is make a list of your possible zeros. And this is just your P over Q. Remember, the P's are the factors of the constant, Q are the factors of the leading coefficient. So I'm going to take 1 and I'm going to make a bunch of fractions. I'm going to take 1 over 1. So take the 1 that's in this factors of my constant, and I'll make fractions placing in the denominator all the different constants of the leading coefficient. So plus or minus 1 over 1, which is just 1. Plus or minus 1 over 2, again, 1 divided by 2. Plus or minus 1 divided by 3, and then plus or minus 1 divided by 6. So again, the factors of the constant are my P. That's the numerator. Factors of leading coefficient, that's the Q, that's the denominator. Now you have to repeat this with the other factor of 2, which is 2. So again, I'm going to make my fractions. 2 is being my numerator. All of these factors of the leading coefficient are the denominator. So plus or minus 2 over 1, which is just 2. Now plus or minus 2 over 2 reduces to 1, which is already in my list. Plus or minus 2/3. And then plus or minus 2 over 6, which is 1/3, which is already in my list. So in this list, what you've just found, without actually solving this equation, in this list, whatever the real zeros or whatever the solutions of this polynomial is going to be, your real zeros have to be contained in this list. So what you can then do from those lists is conjecture some things about some possible zeros based on the graph. Test each potential rational zero by using synthetic division. If you remember from last year when you used synthetic division, if you get a remainder of 0, you know that it is a 0 to that and that is a solution to the equation. Each time a 0 is found, thus a solution is found, you can repeat step B on the depressed equation. Again, the depressed equation comes from synthetic division. And then we can factor and find the other zeros. So remember from last year, and like I just mentioned, if you have a polynomial and it's divided by x minus c, then the remainder is 0 if c is a solution. So to find the remainder, if x cubed minus 4x squared plus 2x minus 5 is divided by x minus 3, remember we can do synthetic division. Remember, you find the 0 of x minus 3, and that's your 3, and that's what goes on the outside of the division. Again, you line up the coefficients from the polynomial, so there's 1, -4, 2, and -5. So remember to bring down your first coefficient. You multiply on the outside. 3 times 1 is 3. You add on the inside. -4 plus 3 is -1. 3 times -1 is -3. Add on the inside. 2 plus -3 is -1. 3 times -1 is -3. -5 plus -3 is -8. Remember, I always circle that last number because that number there is your remainder. So -8 is the remainder when you take x minus 3 and divide it into f of x. So as I kind of mentioned, which this kind of spirals us into the factor theorem, a polynomial has a factor of x minus k if and only if f of k is equal to 0. In other words, when you do your synthetic division, the remainder has to be equal to 0 in order for it to be a factor. So when they ask if x minus 10 is a factor of this polynomial, again, x minus 10, you can do the synthetic division. Remember, I take the 0 that comes from x minus 10, that's what goes on the outside. Line up the coefficients at the top. And we're going to do the synthetic division. Bring down your first term. 10 times 2 is 20. There's 6. 10 times 6 is 60. That's 4. 10 times 4 is 40, and that's 0. So since my remainder is equal to 0, then yes, x minus 10 is a factor. Is x plus 2 a factor of 3x to the third minus 2x squared plus 3x plus 10? Again, we can do synthetic division. Again, the 0 that comes from x plus 2 is -2. There's my 3, -2, 3, and 10. -2 times 3 is -6. -2 plus -6 is -8. It's going to give me 16. 3 plus 16 is 19. -2 times 19 is going to give me -38. So you can see that I do not have a remainder of 0. So therefore, I know that no, x plus 2 is not a factor. So again, that's what we kind of use the remainder in the factor theorem for. Now, this can also spiral us into helping us factor polynomials when all of our other techniques don't work. Factor the polynomial given that f of k is equal to 0. So what I'm giving you is that I'm giving you 1, 0. And as long as you know 1, 0, then you can factor your polynomials by using synthetic division. So what I'm going to do is I'm going to take -2, use my synthetic division. Again, because I'm telling you that -2 is a 0, you should get a remainder of 0. Again, remember, you add on the inside, you multiply on the outside. And you can see you get that remainder. Now, how does this factor it? So remember when we did division and synthetic division? Remember, these are the coefficients of the answers. So remember what I did is I took an x, and I need to drop this down a degree. So again, these are the coefficients of my answer. So x squared minus 15x plus 54 times. Now include the factor that negative 2 came from. Remember, your solution is x equals negative 2. So the factor that negative 2 came from is x plus 2. Remember, you're just putting this in factored form. This is that depressed equation that I mentioned a few minutes ago. So what I now want to do is I want to factor the x squared minus 15x plus 54, which I can do. Factors of 54 that add together give me negative 15 are x minus 9 times x minus 6 times x plus 2. And again, when we get to it, once you factor, you then can very easily find the zeros. So let's take a look at another one. Again, notice I'm giving you a 0 of 6. I want to factor this particular polynomial. So again, I can do that by synthetic division. Again, I'm giving you the solution. I'm giving you x equals 6. So the 6 goes in the front. Line up my coefficients at the top for synthetic division. Always bring down that first coefficient. 1 times 6 is 6. Negative 3 plus 6 is 3. 6 times 3 is 18. Negative 16 plus 18 is a 2. 6 times 2 is 12. And again, you should get a remainder of 0. So now remember, this has an x to the third, and we divide it out. So these are the coefficients of my answer. So again, this is going to be the coefficient of 1x squared. Then I keep going down in descending order. That's a 3x plus 2. Times. Well, if x equals 6, the factor that x equals 6 came from is x minus 6. So the depressed equation is what we get after we do our synthetic division. And that's now the part you want to factor further after you get done doing the synthetic division. So factors of 2 that add together give me 3 are x plus 2 times x plus 1 times x minus 6. So now when you take a look at letter C, again, I'm giving you k is equal to 2. Again, that's where x is equal to 2. So I'm going to do my synthetic division. So my first coefficient is a 4. Now notice you're missing that x to the third, so you have to put the placeholder of 0 there. You're missing an x, you've got to put the placeholder of 0 and then a minus 4. Bring down your first coefficient. 2 times 4 is 8. Remember, you add on the inside. 0 plus 8 is 8. 2 times 8 is 16. Negative 15 plus 16 is 1. 2 times 1 is 2. 0 plus 2 is 2. And then 2 times 2 is 4, which again, you should get that remainder of 0. So now notice you started with an x to the fourth. So when I write my answer, I need to drop it down a degree. So this is going to be a 4x to the third plus 8x squared plus x plus 2. Again, if your 0 is x equals 2, the factor that it came from is x minus 2. Again, you want to factor this depressed equation that we got after we did our synthetic division. So we can factor this by grouping. Remember, you group the first 2, group the second 2. Factor out your GCF out of the first set of parentheses, so I can factor out a 4x squared, and that gives me an x plus 2. Now, there is no GCF to factor out of the x plus 2, but you can always pull out a 1. And now remember the way grouping works, these parentheses should be identical. We factor out that x plus 2, and you're left with the 4x squared plus 1. And don't forget about that x minus 2. So that's how we can use synthetic division. As long as you know 1, 0, that's how we can use synthetic division to help us find the other factors. So like I said, once you factor it, we can then take it one step further. We can find the other zeros and roots. Remember, what you have to do first is you have to factor first. So just like we did in the previous example, I'm giving you a 0. I'm giving you a 5. So what I want to do is factor f of x. So here's my synthetic division. Bring down the 4. Negative 9 plus 20 is 11. 55, that's going to give me 6, 30, and that's a 0. Again, I'm starting with an x to the third. I'm going to drop this down to 4x squared plus 11x plus 6. So now once I come up with my depressed equation from after synthetic division, what I want to do is factor. Because once I factor it, I then can find the zeros by setting each factor equal to 0. So depending upon the method that you use, if I use slide and divide, x squared plus 11x plus 24, x plus 8, x plus 3, divide by 4. So when I factor this, this gives me x plus 2 times 4x plus 3. And again, don't forget about the factor that the 5 came from, the x minus 5. So now I can find my zeros by setting each factor equal to 0. So x is going to be equal to negative 2, negative 3/4, and again, of course, I was given the 5 in the original problem. So like I said, it's taking it one step further. After you do your factoring, you then can find the zeros. So again, I'm giving you the 0 of negative 6. So I'm going to use my synthetic division. Start with my leading coefficient of 1, 2, negative 20, and 24. That's negative 6, negative 4, 24, 4, negative 24, and 0. Again, remember I'm starting with an x to the third, so I'm going to drop it down a degree. X squared minus 4x plus 4. I can factor this into x minus 2 times x minus 2. And again, the other factor that negative 6 came from was x plus 6. So these are my factors. So my zeros come from setting each of the factors equal to 0. So x is going to be equal to 2, and then the negative 6 that was given to me in the beginning. So this is how we can use synthetic division to help us solve polynomials. So now, in all the other examples, I actually gave you a 0. So remember, some similar questions, but the process is the same. I could ask you to find the zeros, find the roots, solve the equation. Remember, you always get started by factoring the polynomial first. And again, always check to see if you can factor first before you have to do synthetic division. Using some of your old techniques, if you can factor first, do it. If you can't factor, that's when you have to jump to the synthetic division. So for example, factor the polynomials and then find the real zeros. So again, I'm going to try to factor this by grouping. So notice I can factor out a 2x squared out of the first set of parentheses. I can factor a 1 out of my second set of parentheses. And since they match exactly, I can factor this into x minus 2 times 2x squared plus 1. So to find the zeros, I take each factor and set it equal to 0. So one of my zeros is going to be 2. Now, if I want to solve the second factor for x, I'm going to subtract 1 and divide by 2. Now notice when I do square root, you end up with a negative underneath the radical. The question's only asking for real zeros. This gives us imaginary. So the only real zeros I have there is 2. Now if you take a look at the second example in part B, grouping is not going to work. So because again, if I factor out an x squared out of the first set of parentheses and I factor out a 2 out of here, those parentheses are not going to match. So here's a case where I'm not giving you a 0 first. So what you want to do, if no 0 is given, use your calculator to find an x-intercept. Remember, an x-intercept will give you the 1, 0. So I'll go to my y equals, I'll type in x to the third plus 6x squared plus 6x minus 4. So one of my zeros, you can either go to your table, second graph. Oh, I need to change something to my table. So you can see how you have 1, 0 at -2. So x equals -2. So one of my zeros is going to be -2. So what I'm then going to do is take -2 and do my synthetic division. And again, I should get a remainder of 0. So I end up with, in factored form, x plus 2 times x squared plus 4x minus 2. So now, again, when I take x squared plus 4x minus 2 and set it equal to 0, I can't factor this. But I do have other techniques that I learned in this unit to solve. I can solve this by completing the square. So I'm going to add 2 to both sides. So now remember, with completing the square, I take the number in front of x, I divide it by 2, and then I'm going to square it. And I add it to both sides. I then can factor this, and 2 plus 4 is 6. And then when I do square root, so x is equal to -2 plus or minus square root 6. These are real zeros. They're just irrational. So your 3 solutions you have are x equals -2, x equals -2 plus or minus square root 6. Like I said, if factoring doesn't work, then that's where you have to jump back and look at your other techniques of solving quadratics. In this particular case, I used completing the square. So again, finding all the real zeros. Again, I'm not giving you a 0. So what I'm going to do is I'm going to look at my calculator and come up with one. Let's see if I can find an x-intercept. Oops. So you can see you have a 0 at 1, 0. You can also use that option under second trace to find the 0 as well. So you see you have 1, 0 at x equals 1. So I can use my synthetic division. Bring down my 1, that's a 3. So this gets factored into x minus 1 times x squared plus 3x minus 5. So again, I already know that I have one solution of x equals 1. I saw that from the calculator. So the other one, I'm going to have to use completing the square on when I set it equal to 0. So I add 5 to both sides. So to complete the square, remember I take the number in front of x, I divide it by 2, and I square it. So I'm going to have to add 9/4 to the left, 9/4 to the right. Remember, whatever number I square, when I factor this, that's what goes inside the parentheses. Remember, you want to factor that. 5 plus 9/4, remember 5 is the same as 20 over 4. So that's going to give me 29 over 4. Square root. X plus 3/2 is equal to plus or minus the square root of 29 over 4. Remember, when you have a fraction under a radical, you can take the square root of the numerator, square root of the denominator. So x is going to be equal to negative 3/2 plus or minus square root 29 all over 2. Again, these are still real numbers because all the numbers under radicals are positive, but again, it's going to be irrational. So that's how we can use synthetic division to help us find the real zeros.